For this problem, we need to find the angle, the sine, cosine, and tangent for a given triangle. In this case, we're given the point 3, -5, which means we have an x-coordinate of 3 and a y-coordinate of -5. We define the sine and cosine and tangent using the ratios sine theta equals opposite over hypotenuse, cosine theta being adjacent over hypotenuse, and tangent as being opposite over adjacent. In our case, for our triangle, the adjacent side adjacent to the angle, is 3. The side opposite the angle is -5. The hypotenuse will be this diagonal side right here. To solve for that, we can use the Pythagorean theorem. Pythagorean theorem says that 3 squared plus -5 squared equals the hypotenuse squared. If we work this out, we find that the hypotenuse equals the square root of 34, which is a little less than 6. So we can write square root 34 right here as our hypotenuse. From here, finding the ratio sine, cosine, and tangent is very straightforward. We can write opposite -5 over square root 34. This is approximately -0.857. Cosine is 3, the adjacent is 3, over the hypotenuse, which is the square root of 34. 3 over the square root of 34 gives us 5.14. Tangent is opposite over adjacent. Opposite side is -5. The adjacent side is 3. So the tangent of the angle is -1.666. Now we can use this, we can use any of these, to get back and find the original angle. To do that, I use the inverse tangent, which gives us the inverse tangent of -1.666 gives us -59.01. 36 degrees. The thing to remember is that sine, cosine, and tangent are ratios. And in using them as ratios, we can always find the proportions that correspond to them. This is very useful for solving for triangles and other such things.